We have run several apps and deployed AI models. Now let me show you how we can use them, how we can use these apps and these models to solve several labeling tasks on LiDAR and DICOM data. Let me start with linear interpolation on point cloud data. So let me open a Kitty dataset first. And I will align myself with this camera, and probably I will move forward. And somewhere here you see this two cars labeled. Maybe I can pick a brighter colors here. Okay, so we have these two cars labeled with cuboids, and also if we go further here to the frame number 23, we will see actually the same cars also labeled with the cuboids, but what we might want to do is to label these frames, these 22, 21, 20, 19 and 18 frames. So we need to interpolate between these cuboids. So let me start with this object first. So this object has two figures. This object has two figures. One figure is located in frame number 17, and the other object is located on the frame number 23. So, and interpolation is quite easy. So what I can do, I can just click select button and go all the way to the end frame here and click interpolate. So that's actually it. And let me show what we have achieved so far. So I will deselect this object and again align myself with the camera. So this was like our original state. But if I scroll further, you see that we have put this frame automatically on the frames that were not labeled. So let me try to repeat this process with this second car. So again, I will select this car, and this car has two figures as previous one. And again, I will select, click select button, go all the way to another annotated figure for this car and click interpolate. And now what we should see if I deselect that all and again just align myself here. So say if I go here, no cars labeled. These two cars was originally labeled, but these annotations on the frames that I am showing right now to you were generated automatically. So this was the last frames that this was actually also labeled frames. And if I open, click on an object here, I will see that this figure was placed like manually, and there is little indication here that these figures were placed automatically. So the next thing that I would like to do is to process the entire point cloud episode with the model that we have previously deployed. So let's do that. Okay, let me pre-label the entire point cloud project at once. So in this project we have Lift dataset and Kitty dataset, and let me make sure that there are no classes. So I will drop this car class so that we are working with empty project. Okay, let me go back. And what I can do, I can run an app from neural networks category here called Apply 3D Detection to Point Cloud Project. Let me run this app. So, and in this app, what we will do, we will rely on the previously deployed model. Let me show you how to do that. So here I will pick the model that we have previously deployed and called 3D detection model. I'll connect to this model. Then this model was trained to recognize certain number of classes. Probably I will just pick all of them. Then I may specify the target project. So let me call it LiDAR demo auto labeled. I may specify confidence levels, some other parameters. So, and then I may specify whether I want to solve just detection task or detection and tracking task. So detection and tracking is better because I want to keep track of detections across point cloud frames. Okay, and then I just click apply module to input data button, and the processing will be initiated. So it will take a couple of minutes for these two data sets to be processed, and I will see you when this process is finished. So I am back and the processing is finished, and the app has generated a new project for us under the name that we provided earlier. So let's click on this project and see the results. So let's first open Lift dataset. And here we should see very good results because recall we deployed the model that was pre-trained on this Lift dataset. So the results should be nearly perfect here. And let me probably do one thing. Maybe I will just disable this option here. So it's not that informative to inspect those results, probably just a sanity check, just to make sure that that everything is processed kind of in a good way. So we trained on this. So the model was trained on this data, and we see that the results are quite good. Way more interesting case is Kitty, because the model wasn't trained on Kitty, and let's open a Kitty dataset to see how well the model performed. Because say if the model works good here, it actually means that we could use this module to pre-label our data, and since the labeling on point clouds is very hard, this pre-labeling is very efficient, very essential. So let me probably show object IDs here just to illustrate that the model not only detects but also tracks here. And I can proceed in this manual way. And you see that the quality is actually quite good, and it is very beneficial to run this kind of models before manual labeling, because we don't have to start labeling from scratch. We may rely on these initial predictions and start from there, not from raw data. Okay, so probably I should stop here and move to the DICOM.